In this video, I'm going to work through example problems 2 to 4 on your Properties of Quadratics lesson. I do encourage you to try the problems on your own, but if you are completely stuck, you can just watch the whole thing, or you can watch parts of the videos just to get you started. So the first question says two whole numbers differ by 3. The sum of their squares is 89. What are the numbers? So it's asking us to determine the two numbers. So let's represent the first number by a letter. Suppose we let x be the first number. And we need a second number. So suppose we let y represent the second number. Now, there's a bit of an issue here. We have two unknown variables, and I don't want to create a system of equations and solve for these two unknown variables. But I'm actually going to change this y. I want to replace this y with something that has an x in it. So we know from the question two whole numbers differ by 3. So if I took my second number y and I subtracted my first number x, our difference would be 3. But we can rearrange this little equation that I created here. We want to find another expression that y is equal to so we can get rid of that y and just use x. So if y minus x is equal to 3, if we just isolated y and moved that minus x over to the other side, we would get y is equal to x plus 3. So we can actually replace this y with x plus 3. Now we're only working with one variable, and we're working with just the x. So x represents our first number, and x plus 3 represents our second number. The next part of our question says the sum of their squares is 89. So we can take our two numbers, square both numbers, add them together, and we're going to get 89. So we would get x squared plus x plus 3, all of that is squared, and that's equal to 89. Now we have an equation that we can work with. We have one variable x that we can solve for, so let's actually start simplifying this and then solve it. This x plus 3 squared, we want to simplify that. That's the same thing as x plus 3 times x plus 3, so we need to distribute. And we're going to keep that x squared in the beginning, and then when we distribute and FOIL that x plus 3 squared, we're going to get x squared plus 6x plus 9, and that's equal to 89. We can still continue simplifying because we do have a like term here, x squared plus x squared, so this just becomes 2x squared plus 6x plus 9. And we have a quadratic here that's equal to 89. So we want to solve for x. How do we solve for x here? Well, in order to solve a quadratic, we need this to be equal to 9. So we need to move this 89 over to the other side. And we do that by subtracting 89. So once we do that, we get 2x squared plus 6x minus 80, and that's equal to 0. So we can solve this equation by either factoring or even using the quadratic formula, but I'm going to try to factor this. And if you notice, we do have a common factor between these three terms. Our greatest common factor is 2. So since this is an equation, I can divide both sides of the equation by 2. So when we divide by 2, the left side becomes x squared plus 3x minus 40, and on the right side we have 0 divided by 2, and that's just 0. And this is just an equivalent equation that's going to give us the same solutions. Now let's try to factor this. Our coefficient in front of the x squared is just 1, so we could use sum and product. So we're going to find two numbers that multiply to give us negative 40. But when we add those same two numbers, we're going to get a positive 3. So our two numbers are 8 and negative 5. 8 times negative 5 is negative 40, and 8 minus 5 is 3. And to write this in factored form, it's just x plus 8 times x minus 5, and that's still equal to 0. And now we need to solve for x. So we're going to have two possibilities. what value of x would make x plus 8 equal to 0? So our first x is just equal to negative 8. And then what value for x would make x minus 5 equal to 0? And our second x is positive 5. But we're not done yet. We found two possibilities for our x values, but that's just our first number. X is our first number, but x plus 3 is our second number. So we need to use this x plus 3 to get our second number. So we have two possibilities when x is either equal to negative 8 or when x is either equal to positive 5. And for our second number, we're going to have x1 plus 3. So that's just going to be negative 8 plus 3, which is just negative 5. So that's our second number. And when our second value for x is equal to 5, we can just have x2 plus 3. And that's just 5 plus 3. So our second number in this case would just be 8. Therefore, the two numbers are either negative 8 and negative 5, or 5 and 8. This definitely isn't the only way to solve this question. You may have approached it in a different way, but this is the final answer. So in this next question, the base of a triangle is 2 centimeters more than the height. The area of the triangle is 5 centimeters squared. Find base to the nearest tenth. So we know we're working with a triangle. We know triangles have a height and they have a base. And the question says that the base of the triangle is 2 centimeters more than the height. So that means our base here is our height plus 2. So we could change this b into h plus 2. We're also told in the question that the area of the triangle is 5 centimeters squared. So how do you find the area of a triangle? Well, our formula is just area is equal to base times height, and that's divided by 2. So we can start filling in all the information that we know into this equation. A is just equal to 5. Our base, instead of b, we're just going to replace it with h plus 2. And height is just h. And that's all divided by 2. So our only unknown variable here is just h. And we have this fraction here. We can multiply both sides by 2 just to get rid of the fraction. So we're just going to get 10 is equal to h plus 2 times h. And we need to simplify this, so we need to distribute that h into the brackets. So we're just going to get 10 is equal to h squared plus 2h. And we need to solve for h. So we need our quadratic equal to 0, which means we got to move that 10 over to the other side by subtracting 10. So we're just going to get 0 is equal to h squared plus 2h minus 10. And now we just need to solve this quadratic. It doesn't look like this quadratic is factorable, so I'm just going to use the quadratic formula. And once you input the a, b, and c values, you're just going to get h is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 10, negative 10. And that's all over 2 times 1. And when you simplify that a little bit, you have two options. So you're going to get negative 2 plus the square root of 44 over 2, or negative 2 minus the square root of 44 over 2. Now input that into your calculator. You're just going to get 2.3 approximately, or negative 4.3. But negative 4.3, we can't have that. We can't have a negative value for a height. So that's not part of your answer. And now we're just going to use that value for h to find our base. So our base is equal to h plus 2, and that's just 2.3 plus 2. So our base is just equal to 4.3. And this is actually all in centimeters. So in the next question, it says that Chris and John are cutting a rectangular lawn 40 meters by 40 meters. Chris starts mowing strips of equal width around the perimeter, while John starts cutting a rectangular patch in the middle. And the question asks, how wide a strip should Chris cut so that they share the work equally? So we're trying to find out the width of this strip, and we can represent that with x. So Chris cuts this gray area along the perimeter, and John cuts the area in green in the middle. We know from the question that both Chris and John share the work equally, so that means the total area of the lawn is split in half. So we can find out how much area each person cuts. So the total area is just going to be 30 meters multiplied by 40 meters, and that's just 1,200 meters squared. And then we can divide that area in half. So our area is just going to be 1,200 divided by 2, so each person will cut 600 meters squared. Since each person cuts 600 meters squared, you can either come up with an equation that is the area of this gray part, which is Chris, or you can come up with an equation that is this green part, which is John. Coming up with an equation for this green rectangle here seems a little bit easier, so I'm just going to do that. So we know the area of a rectangle is just length times width, so we need to write an expression for the length of this rectangle and the width of this rectangle. Since the question says that Chris mows strips of equal width around the perimeter, the width of each strip on the edge is just going to be x. And we're going to use that to come up with an expression to find the length of the smaller rectangle and the width of the smaller rectangle. So since the entire lawn is 40 meters, we need to subtract x from each side of the lawn. So this is just going to be 40 minus 2x. And we need to do the same thing with the width. We need to subtract an x from each side of the width. So the width of our smaller rectangle is going to be 30 minus 2x. We know the area that they each need to cut is 600 meters squared. And to find the area of the rectangle, we're just doing our length times our width. So that's just going to be 40 minus 2x times 30 minus 2x. Now we can actually simplify this equation. So we have a binomial times a binomial, and we just need to multiply these using FOIL. And when we do that, we're just going to get 600 is equal to 1,200 minus 80x minus 60x plus 4x squared. So we need to simplify this further. We can combine these two like terms, but also I want to move that 600 over to the other side, so we have a quadratic that's equal to 0. So when we subtract 600 and we combine our like terms, we just get 0 is equal to 600 minus 140x plus 4x squared. And we need to solve for x. So we can either factorize the quadratic formula. Some of these numbers are actually really big, but there is a common factor here. So our common factor is 4. So since it is an equation, I could divide both sides by 4. And that's just going to give me an equivalent fraction with some smaller numbers, but we will get the same solutions in the end. So this is just 0 is equal to 150 minus 35x plus x squared. And let's just actually rearrange this so that it's in the proper order of standard form. So we're going to get 0 is equal to x squared minus 35x plus 150. And to solve this, we can actually factor it. So we're finding two numbers that multiply to give us 150, but when we add those two numbers, we get negative 35. And those two numbers are negative 30 and negative 5. So to rewrite this in factored form, it's just going to be x minus 30 times x minus 5. And we want to solve for x. So we're going to get two possibilities for x here. So what value for x would make x minus 30 equal to 0? Well, that's just x is equal to positive 30. And what value for x would make x minus 5 equal to 0? and that's just when x is equal to a positive 5. So can we actually have two possibilities for the value of x? Well, let's look at our first x. If x is 30, well, does that even make sense in our diagram? Our width is equal to 30, so there's no way that this strip of x could be equal to 30. So that's not one of our answers. That's definitely way too big. Our only answer is going to be x is equal to 5. So this means that the width of the strip is just 5 meters. And we are done.